Hello students, this is Mr. McAllen again, and we're going to work on 11 and 12 on the midterm review for the open-ended. Hopefully this video is helpful to you. And in the first one, they want us to compare or describe how the function 2 to the x minus 3 minus 4 is positioned relative to 2 to the x. So remember, you can always use a table. You have access to your note card. There are lots and lots of things that you can do to help you get through this problem. Preparation is the key. So remember, 2 to the x is a very simple function to graph. I'll just graph its parent function over here. When you plug in 0 into the function, you're always going to be at a value 1. When you plug 1 in, you're going to be at the value 2. And when you plug in -1 to the negative first, is going to be 1/2. So your exponential growth function will look like such. And this is your basic parent function for an exponential growth. And if you look over here at this graph, you're going to see that two things happen. You have translation to the left, translation to the right by 3, because x minus 3 set to 0 tells you that the function moves over 3 right, and that -4 on the outside pushes the function down by 4. So it's going to move down 4 units. So if you take these 3 points that we had, 1, 2, 0, 1, and -1, 1/2, and remember there's also, that comes with this function, an asymptote. An asymptote at y equals 0. All of these parts, the points, move over to the right by 3, and move down by 4. So just move the points. I'll first move the asymptote down 4 because that helps me as a guide. I don't like this graph, so feel free on the midterm to draw your own graph and label your tick marks. So it's going to go down 4. So here's my asymptote, y equals -4. The point on the left is going to move over to the right by 3, so it's going to go, when I add 3 to the x coordinate, I'm going to get 2. And it's going to move down 4, so that's going to be at 3.5. So I'll label that, and make sure you label your points, 2, 3 and 1/2. My next point is going to be at 3. It's at 0, 1, so it moves right 3, down 4, so it's going to be at 3, -3. So it's going to be right there, 3, -3. And my last point is going to go from 1, 2 to 4, 2, -2, I should say. Pardon me. So I have 4, -2. So I've moved all my points right 3, down 4, move my asymptote, and I draw my function, and I could describe, if it asked me to describe in writing how it moves or through a graph, I've managed to do that, and always write down what the function equation is. So this is 2 to the x minus 3 minus 4. So hopefully that's helped you with that one. Now we have another equation to work with, and this is 4 to the x. So how does 4 to the x, -4 to the x minus 1 move relative to 4 to the x? Well, I'm going to graph 4 to the x again with my 3 points. Remember, I have an asymptote at 0. At 0, I'm graphing 4 to the x. At 0, I'm at 1. At 1, I'm at 4. And at -1, I'm at 1/4. So again, this is a growth function. And I'm going to label these points just so that I can use them later. And now I'm going to identify what type of movements I have for this function. That negative is a flip over the x-axis. Remember, the negative in front of the function flips over the x-axis. If the negative were in front of the variable, that would be a flip over the y-axis. but there is no flip over the y-axis, so I don't want to confuse anybody. But that's just really for just general information. You never know. On the midterm, we may give you a couple flips or a different flip than what you anticipate from the review. And it looks like the superscript is x minus 1. It looks like the function is -4. I'm going to judge it like this. It's -4 to the x minus 1. So I'm reading this function to be a movement left-right. So this is going to move to right 1. So I view that to be up in the exponent spot, that x minus 1. So what I'm going to do with my graph is I'm going to use these points that I just plotted before, and I'm going to just move their points based on, I have to take care of flips first. So all of my points are going to flip over the, x-axis, and then they're going to move right by 1. So if I flip my asymptote over the x-axis, it stays at 0, and moving that asymptote left or right, it's still gonna, my asymptote is still gonna be at y equals 0. So now what you do is point per point, you flip first, and then you translate. So my -1 1/4 is gonna flip below the x-axis, so it's gonna be down here. That's at -1, and now it's gonna move to the right by 1. So it's gonna go over here to the, it's gonna lie on top of the x-axis, and the coordinate for that first point will be 0, -1/4. My next point is at 0. It's going to flip over the x-axis, and it'll end up at 0, -1, and then it translates right 1. So it's going to be right here at 1, -1. And my last point, that's at 1, 4, it's going to flip and go to it's going to go to 1, -4. And then it's going to move to the right by 1, so it's going to be at 2, -4. So, and then you connect the dots with the exponential curve, and hopefully you see you've made the transformation successful with -4 to the x minus 1 equals your function. Hopefully this video has helped you refresh your memory on how to plot exponential functions with translations using nice, simple point-for-point plotting for the parent function, and then you do your transformations with those points.